Welcome back to The Explainer. Today, we're unpacking what is genuinely shaping up to be a real-time cosmic detective story. We are talking about a massive structural paradigm shift happening right now in modern physics. If you're into understanding the absolute foundational mechanics of our universe and how new, hard data can literally rewrite the textbooks overnight, well, you're in the right place. Let's dive right in.
I want you to think about this quote for a second, pulled straight from the research we're unpacking today. It says, "It was watching the field unknowingly walk right up to the edge of ACS." What that implies is actually wild. It means the global physics community, through completely independent observations and data analysis, is currently standing on the precipice of a full-blown scientific revolution. They are staring at data pointing directly to a new framework called Adaptive Computational Spacetime, or ACS. So how exactly did we get here? Let's trace the steps.
Okay, part 1. Cracks in the cosmos.
To understand the new solution, we obviously have to understand the current problem, and our primary suspect here is the standard FLW model. Now, you know the deal. It's been the bedrock of cosmology for decades. It assumes the universe is basically a smooth, continuous rubber sheet expanding uniformly everywhere with just a single scale factor and constant curvature. But here's the thing. Empirical reality is currently telling a totally different story. The source material is pointing to major structural failures of those exact assumptions. The universe is actually exhibiting variable curvature and distances that depend entirely on the direction you happen to be looking. That smooth rubber sheet, it is absolutely cracking.
And the most crucial point here is that these deviations, they aren't just tiny, negligible rounding errors. The data is showing structural failures at the 2 to 4 sigma level. If you follow physics, you know that when you hit that level of deviation across multiple, model-independent tests, your standard model's alibi is falling completely apart. The inconsistencies are undeniably real, and it means we need a fundamentally new explanation.
Moving on to part 2, 3 clues pointing elsewhere. So there's this really clear, established trail of evidence spread across 3 major research papers. And what they did was systematically strip away all those old mathematical shortcuts just to look at the raw cosmos. Step 1. The first paper introduced mechanisms like Dyer-Roeder optical inhomogeneity and geometry-driven expansion. Essentially, they proved that curvature varies with redshift. Okay. Step 2. The second paper just straight up removed the standard FLRW math to derive generalized distance and expansion metrics valid in any arbitrary spacetime. That proved things actually change depending on the direction you look. And finally, step 3, the third paper reconstructed the raw observational data without assuming any prior smoothness at all.
How did they pull off that final step? Well, they used something called symbolic regression. This is an incredibly powerful AI data analysis tool that reconstructs equations strictly from the raw data itself. By using symbolic regression, researchers successfully avoided imposing any human biases, like that whole FLW smoothness prior we were just talking about. And it turns out this was the exact detection pipeline that uncovered those undeniable 2 to 4 sigma deviations. The math simply matched the messy, cracked reality of the cosmos rather than our neat theoretical assumptions.
Which brings us to part 3, the geometry-first universe.
Enter the radical new solution that actually fits perfectly into all these cracks: Adaptive Computational Spacetime, or ACS. And ACS models the universe in a completely fascinating way. First off, there is no background manifold or embedding space. It's not just some empty vacuum container. Instead, spacetime is built out of fundamentally discrete causal links. Think of it like a digital pixelated network of intervals, known as partially ordered sets. There is absolutely zero smooth, continuous physics below the Planck length. That's a hard physical floor. So what we perceive as smooth, macroscopic dimensions, they actually emerge dynamically from the diffusion of this underlying network. It is a total game changer.
Now you might be asking, so what? Why does a complex discrete geometry matter? Well, it matters because of the mysteries it solves. Look at how this lines up. ACS's spectral curvature neatly resolves the infamous Hubble tension. Its emergent expansion naturally creates back-reaction-like effects. The fact that its observables are anisotropic, that perfectly matches those non-FLRW distances found in that second paper. And its lack of a global scale factor naturally accounts for the optical inhomogeneity. It's like a giant puzzle coming together. The unique math of ACS is flawlessly solving the biggest, most stubborn mysteries currently plaguing modern cosmology.
All right, part 4, the AI verification experiment.
Naturally, you can't just propose a massive paradigm shift like this without some incredibly rigorous testing. To verify if these papers truly converged on the ACS framework, researchers set up a massive, multi-model computational audit. We're talking a completely decentralized testing pipeline utilizing 4 distinct AI architectures. Meta handled coordination, pre-registration, and the falsification checklist. Grok was assigned adversarial testing, basically serving as a harsh auditor with a built-in kill switch. Gemini functioned as the physics-forward model, actually simulating those discrete causal poset networks, and Copilot managed the pipeline orchestration and the symbolic regression. All 4 of these completely independent architectures independently converged on the exact same geometry-first interpretation.
Actually, let's be super precise here for a second. This convergence is empirical evidence of a low-entropy structure hiding in the data itself. It is absolutely not AI sentience. The AI didn't suddenly wake up and invent a new universe. The models functioned strictly as complementary inductive biases. They acted as incredibly powerful pattern-matching engines, recognizing the true underlying mathematical structure that was already hidden inside our cosmological data.
And this spectacularly rigorous pipeline led to one very specific number, 2.021. Now, this isn't just an interesting theory. It is a hard, falsifiable prediction. The ACS framework predicts that the effective spectral dimension of the universe at a co-moving distance of 100 megaparsecs is exactly 2.021. This proves ACS is a rigorous and testable mathematical framework. If future large-scale structured data doesn't match this number, the framework is falsified. This is real, hard science at work.
Finally, part 5. Are we ready for change?
So the math works. The data matches perfectly, and 4 different AI models verified the patterns. But are human physicists psychologically prepared to accept a paradigm shift of this magnitude? Well, data from an APS survey of 1,675 physicists tells a pretty surprising story. We constantly hear about the rock-solid consensus of the standard model, right? But the survey shows only 51% view cosmic inflation as the solution, only 24% point to lambda as dark energy, and literally only 20% view the Big Bang as the true beginning of time. Looking objectively at these numbers, the physics community is actually deeply fractured on the core pillars of the standard model.
The survey analysis noted something really critical. It said, several positions often described publicly as consensus views are supported by much narrower majorities. What this means for our cosmic detective story is huge. It means there's no monolithic, overwhelming consensus standing in the way, blocking a geometry-first alternative. The psychological runway for a new model like ACS is completely clear and ready for takeoff. So let's bring all these threads together. You've got the 3 observational papers revealing the 2 to 4 sigma cracks. You have the rigorous 4-model AI verification experiment, and you have the APS survey showing the community is ready. Together, they form a coherent, multi-angle confirmation. Empirically, computationally, and sociologically, everything is pointing to the fact that the physical universe behaves exactly as if this discrete, ACS-style geometry is running underneath it all.
I want to leave you with a final, provocative thought. Think about the space right in front of you. What happens to our understanding of reality when you realize the empty space between you and the screen you are looking at right now isn't a smooth, empty vacuum at all? What if it's actually made of discrete, computable network nodes? It fundamentally rewrites our entire place in the cosmos. I really hope this explainer gave you a clear, structured look into the incredible, cutting edge of modern cosmology. Keep questioning, keep looking at the data, and I'll catch you next time.